Good morning, teacher.
Uh, good morning. So, can you hear me? Can you hear me clearly? Please, you can either send a reaction or message in the chat box if I can be heard clearly. Okay, so good morning again. I am Coach Carlene, and I will be so we will be reviewing the some problems in preparation for the HKIMO final round. So, okay, so I think we can start. Okay. Okay, so first problem, this first question. So given A and B are two non-zero digits and the two-digit numbers formed by this two digits have the following properties. So the first property is that AB is divisible by 9. And the second property is that the difference between VA and a square number is 1. So we are asked to find the two-digit number AB. So AB with a line, first of all, just want to make this clear for everyone. Want to make this clear for everyone that this basically means a two-digit number where the tens digit is A and the ones digit is B. So in case you haven't encountered that notation before. Okay, so let's start. So can anyone answer? I mean, in the chat box, what is the divisibility rule of 9?
So sorry, I cannot use the chat box. The
Oh,
chat is dis
can you
the chat is disabled.
no? Oh, no one can. No one.
No,
Yeah,
teacher, chat board is disabled, teacher.
Okay.
the chat is
Oh,
disabled, so we can.
you can you can uh you can speak in the microphone instead if you cannot type
Oh,
in the chat box.
okay.
So does anyone want to answer what is the divisibility rule of 9?
Like 9 itself, and then 18, 27, 36, and more until 99.
Okay, but sure, but what 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 condition do you need to satisfy so that the number is
Multiples of 9.
so that a number is considered divisible by 9? So
Um,
okay, someone raised hands. So okay,
if the sum of all the digits are divisible by 9,
okay, yes, that's exactly the divisibility rule of 9. So for any number, so in this case AB, so if this is divisible by 9, this means that the sum of digits A plus B, this must be also be divisible by 9. So this means that since A and B are one digit numbers and they are non-zero, we have the possible values of AB would be 18, 27, 36, 45, 54, 54, 63, 72, 81, and 99. And 99, 99 cannot be included here since it's emphasized in the problem that there are two non-zero digits, so they cannot have the same value. They can have the same value, so A and B have to be different, so they cannot be both 9. So 99 is not a possible value here. Okay, so then for the second condition, we then switch the digits. For this is 81, 72, 63, 54, 54, 45, 36, 27, and 18. So the second condition, it says that the difference between BA and a square number is 1. So with this, we're gonna eliminate all the cases where BA is a square number. Since it cannot be a square number, we're gonna eliminate this case and this one. So, okay. So for 72, the nearest square number the nearest from 72 is 64. However, the difference isn't 8, so this is not the answer. And for 18, the nearest square number from 18 is 16. And the difference is also not 1, so that is not our answer either. For 27, it's 25. The difference is also not 1. For 45, the nearest is 49, and the difference is also not 1. For 54, it's also 49, but the difference is also not 1, so this is not the answer. For 63, the nearest square number is 64, and the difference is 1. This means that our answer is 36. B is equal to 36. So are there any questions? None?
No, teacher.
Okay. So let's proceed. Okay, so this is
Miss, I wanna ask something.
okay. Sure.
Uh, Why the answer is 36? Why not 63?
Why not 63? Because if you reverse 63, that would be 36. And 36 is a square number, and it doesn't satisfy the second condition. Here the order matters in the order of the digits matter in this problem. So the answer is 36. Does that answer your question?
Oh, yes, miss. Thanks.
Okay. Okay, so now our questions. Okay, we'll proceed to number 2. So Peter goes west for 23 kilometers, then goes north for 12 kilometers, and goes east for 18 kilometers. How far is he now from the original position? So for this problem, I think it's easiest if we have some kind of visual. So this is the north, this is the north, this is the east, this is the west, and this is the south. So let's say this is the original position of Peter. So we'll label this big P. And it says that Peter goes west for 23 kilometers. So we'll draw a long line, and this 23 kilometers. And from here, then goes north for 12 kilometers. And goes east for 18 kilometers. So now Peter is here, and we're asked to find this distance. So there are two components. So there are two components to this distance. There is a horizontal distance and there is a vertical distance. So the vertical distance is this one. So that's 12 kilometers. I'm also going to write 12 here. And the horizontal distance is the difference of 23 and 18. So this is 5 kilometers. So gonna write 5. So if you're familiar with the Pythagorean triples, you can immediately see that the answer should be 13. But if you're not familiar, I can show you the Pythagorean theorem instead. So if we want to find this, what we're going to do is square this, square 12 and 5, then add the squares. So this should give us 144 plus 25, which is equal to 169. So 169 is, so if you're familiar with your squares, you would see that 169 is equal to 13 squared, which satisfies the Pythagorean theorem where a squared plus b squared is equal to c squared. So that means that Peter is 13 kilometers from his original position. In the actual exam, you don't have to include the units. You just need to put your answer. So you just need to put 13. But I'm just gonna put it here in this question. So are there any questions for number 2? None? Going once?
No, teacher.
Going twice. Okay. So no questions for number 2. Now let's proceed. Okay, number 3. So if A, B, C, D, E, F plus A, B, C, D, E, F is equal to C, D, E, F, A, B, calculate A, B, C, D, E, F. So it's this, so the notation for this number is the same in number 1. So this is a 6-digit number, and A, B, C, D, E, F are essentially 1-digit numbers. So for this problem, I will split this into 2 numbers. So we now have A, B, and C, D, E, F. So I'm going to label this as big X, and I'm going to label this as big Y. Okay. So so we can represent A, B, C, D, E, F as 10,000 X plus big Y. And we can represent C, D, E, F, A, B as 100 big Y plus X. So we multiply this by 2 and put the cosine. So this is now our new equation. So this is now our new equation. We just derive from this original equation. Okay. So if we simplify this, we get 20,000 X plus 2Y is equal to 100 big Y. 100 big Y plus X. And if we get rid of 2Y here and X here, we get 19,999 X is equal to 98 Y. Since we don't know what big X and big Y is, it's pretty hard to solve. It looks pretty hard, but so how we're gonna do this is we're going to find the factors of 98 since it's the smaller coefficient. So 98 is equal to 2 times 7 squared. You can check this for yourself. Since this number is obviously not divisible by 2, we'll try dividing it with 7 instead. So I'm doing this so that we can find the common factor, which we can hopefully simplify that, make the equation easier to deal with since the numbers are very big. So dividing this, we get 2 is 14, it's 59. 59 divided by 7 is 8, which gives us 56. This is 39. 39. 39 divided by 7 is 5. This is 35. This is 49. And 7 times 7 is 49. So fortunately, 19,999 is divisible by 7. So we can take out 7 from, we can divide the equation by 7, I mean. Okay. So if we divide the entire equation by 7, we get this 14 big Y. So can I ask you if So we know 14 is equal to 7 times 2. But can I ask you if, can you answer if this number is divisible by 7?
No.
No, di siya.
Okay, it's not divisible by 7. So this means that 2,857 and 14 have no common factor that is not 1. So you can also call them co-prime numbers since they don't have a common factor that is not 1. So this means since we know that x and big Y are positive integers, the only solution for this equation is if x is equal to 14 and if y is equal to 2,857. So we go back here. So this is 200,857 and this is 14. So now we have our answer. So A, B, C, D, E, F is equal to 14,400. 142,857. So we can check this for ourselves. So we're going to add this, get 14, 11, 31, 6, 17, 5, 28. So this satisfies the what we see here in the given. So indeed, this number is our answer. Okay, any questions?
Why is it 10,000x and 100y?
Oh, okay. So why, so you're asking about how I represented the numbers. Okay. So big X is this number and big Y was this number. So that's what I assigned. Since A, B, C, D, E, F, since this is a 6-digit number, so you will have to you need to add 4 zeros in front so that you can just add the value of y. Since if you do like x plus y, that's technically this will technically give you a 4-digit number, not a 6-digit number. So if you want to represent this in terms of x and y, you would have to multiply this by, you would have to add 4 zeros. So that means you need to multiply it by 10,000. So you can just add y here. So that is A, B, C, D, E, F. For the case of C, D, E, F, A, B, so this is y. And you want to add 2 zeros. So you're going to multiply it with 100. So you can then just add x. Does this answer your question? Okay.
Okay, thank you.
No more questions? Okay, none. So we can proceed to the next question. Okay. Number 4. So 12 May 2018 is Saturday. Which day? It should be day of the week. Will 12 May 25th, 2025 be? So fortunately, we have the same. The only difference is the year. So the only difference here is the year. It's both 12 May. So calculating the number of days in between will not be very tedious task. So 2025 minus 2018. So this is 7 years. This is 7 years. And we know that for common years, like for normal years have 365 days. However, if it's a leap year, and if you want to know whether if it's a leap year or not, you just divide the year by 4, and if there's no remainder, then it's the leap year. So if it's a leap year, it would have 366 days. So it has one extra day. One extra day compared to the normal 365. So in between 2018 and 2025, we have 2 leap years, I think. 2022, 2023, 2024, 2025. Okay, so these are the years. So 2020, if you want to check it for yourself, the leap years are 2020 and 2024. So we have 2 leap years. So what this means is that the total days between this May 12, 2018 and May 12, 2025, it's 365 times 7 plus 2. Since you have 2 leap years, that means 2 extra days. So if you compute this by hand, you should get. Okay, do you have a question? Someone raised their hand.
Yeah, 365 equals 1 mod 7, so I can just treat it like 1 and not have to calculate. Because there's just a remainder of 1. So it's 1 extra day, yeah.
Can you repeat your question? I'm sorry.
If I go 365 days, 365 divided by 7 leaves a remainder of 1. So I can just write 365 as 1.
Yes, that's also a valid solution. It is true that if you divide 365, the remainder should be 1. However, I'm showing here like the usual solution. So if you calculate the number of days, it should be your answer. And the next step should be finding the remainder when you divide it by 7, which we technically don't have to do here since this is the equation. It's pretty clear what the remainder should be. Which is 2. So if we divide this by 7, we should get a remainder of 2. So what this means is that this date is 2 days after Saturday. So 2 days after Saturday should be 1, 2, a Monday. So, okay, so the answer is a Monday. Alternatively, we can also use what was suggested, and instead of putting 365 days, we can just replace it with 1, since 365 divided by 7 leaves a remainder of 1. So that's it for this question. The answer is Monday. Any questions?
No, teacher.
Okay. Okay, no questions. So we can now proceed to the next problem. There are 30 problems in a mathematics competition. The scores of each problem are allocated in the following ways. 5 marks will be given for a correct answer, 0 marks will be given for a blank or a wrong answer. Find the minimum number of candidates to ensure that 4 candidates will have the same scores in the competition. Oh, wait. Okay, sorry. So, sorry. So, is the screen visible? I mean, my share screen.
Yes.
Okay. Okay, sorry about that. So for this problem, here we have for each correct answer, you get 5 points. And if your answer is blank or a wrong answer, you get 0 points. So this one is pretty straightforward. Okay. If this is the format for marking the answers, this means that the possible scores are 0, 5, 10, 15, so on and so forth. Basically, just multiples of 5 until 150. So if you count this, you should get 31 possible scores. Should get 31 scores. And to ensure that 4 candidates will have the same score, we should consider the worst case scenario where there are 3 candidates that each obtained each score. So what I mean by this is that there are 3 candidates that got 0, 3 candidates that got 5, 3 candidates that got 10, 3 candidates that got 15, and this goes on for every possible score until 150. So with this, we then now have 31 times 3 students, which is 93. And we will then just add 1 student so that whatever the student gets, we can ensure that there are 4 candidates that have the same score. So 93 plus 1, that is then just 94 students. So this is our answer. Are there any questions?
Miss, I wanna ask, why is there have 3 candidates on each score?
Why are there 3 candidates? Because simply because to ensure that Okay. So for me, it's just because 3 plus 1 equals 4. So what I mean by this is that if you put three candidates, that, okay, sorry, that wasn't a good explanation. I'll start over. So we need the minimum number of students, and sure, we can technically just do 31 times 4, but that's not exactly the minimum number of students that we need to satisfy the condition in the problem. So as I said earlier, 3 plus 1 is equal to 4. So if we have 3 students that obtained like 0, there are 3 students that got 5, etc., etc. So if one more student takes the test, whatever score they will get, we can make sure that there are 4 students that got the same score. So let's say this student got 15. Since we know that there are already 3 students that got 15, we can just add 1, and now we know that there are 4 students that got a score of 15. Similarly, if they got a score of 30, we made sure that there are 3 students that got a score of 30. So if we add 1 more, it's going to be, there is now 4 students that got a score of 30. So whatever score the last student gets, so we want to make that scenario where whatever the score of the last student, we can make sure that there are 4 people that got the same score. Does that answer your question?
Yes, Miss. Thanks.
Okay. Okay, so no more questions? No more questions. So we'll move on to question number 6.
Arisha, I want to add,
Okay.
Arisha, if it possible to add +2 behind 93.
Add plus 2.
93 +2, is it possible? Sure.
That would not be the minimum number of candidates. Since we only need to add 1. If we have 93 students already, we only need to add 1 more. Does that make sense?
Yes, Tisha. Thank you, Tisha.
Okay, so next question. Now the light is on. Amy presses the light button to 2018 to the power of 2014 times. Can you guess whether the light is on or off? So the only thing we need to know here is whether, okay, it's whether the number is even or odd. So I made a mistake again. Sorry. So I'll just use this to explain. So if it's even, then the light should be on. And if, wait,
Where is the question 6?
wait. I'll stop sharing for a second. Okay, is this visible?
Yes.
Okay, so
Yes.
the only thing we need to know is whether this is even or odd. So if it's even, then the light stays on. If it's odd, the light goes off. So if we're going to recall this, if you multiply an even number with another even number, your product should be even. How about if you multiply an odd number with another odd number? Your product should be an odd number. And can anyone answer what you should get if you multiply an even number with an odd number?
Even number.
Yes,
Even number.
you should get an even number. In this case, we are just repeatedly multiplying an even number with an even number. So since here we should get an even number, and if we multiply this by an even number, it's still even, and so on and so forth. So now we're sure that this number is even. And we establish here that if it's even, the light is on. So therefore, the light is, if you press the button this amount of time, I mean by this number, the light should still be on. So any questions?
No, this
I think we can proceed.
I wanna ask if 2018 kan number is even, so the light is on. That's it.
Can you ask your question again? I didn't catch that.
Okay. So the number 2018 drag to 2014 times is even, so the light is on, because if you off and on again, that's even.
Yes. So that's why the light is still on. Yes, that is correct.
Okay, thanks, Miss.
Any more questions? Someone raised their hand.
2018 to the power of 2014 is older than the age of the universe.
I see. But we're not really concerned with the scale of the problem. We just need to know if it's an even or odd number. So with that, I think we can proceed to the next question. So find the value of y if the absolute value of x plus 901 added with the square root of 902 minus y equals 0. So anything that you put in the absolute value function and the square root, so whatever a, b, this is, so whatever you put in here, the answer can only be non-negative. What I mean is, you cannot configure a or b in such a way that you will get a negative answer when you take the absolute value or the square root. So if the answer is 0, then that means that this and this should both be 0. So since we're only concerned with the value of y, we'll just take this 902 minus y is equal to 0. And this is only possible if 902 minus y is 0, which means that y should be equal to 902. So that's it for this question, or that's it for this number 7. Are there any questions? Yes? Someone raised their hand. Can you?
Yeah, don't square will have negative answers. Like
Okay.
4 can be -2 because -2 square equals to 4.
Okay. So that is a common misconception. The thing is, so you're talking about, okay, let's say you have x squared equals 4. So yes, x would be plus minus square root of 4, or simply just plus minus 2. However, if we're talking about the square root of 4, this should only be 2. Why? Because the square root as a function cannot produce negative values. So if you see it in an expression, you should assume that you don't take the negative answer. So you only consider the negative answer when it's written like this. So when it's written like this, like x squared equals the answer. So if you want to solve this, you're gonna have to take the square root. So if that's confusing, so a tip that I can give you is that if you're the one who puts the square root, then there should be a plus minus. So, but if the square root is already there, then you should only assume the positive answer. So in this case, since we're the ones who's putting the square root, we should consider both positive and negative solutions. But in this problem, the square root is already given, so we only need to consider the positive answer. Does that answer your question?
Yep.
Okay. So no more questions? None? I think we can proceed.
Teacher, I want to ask.
Okay.
Teacher, if the equation is equals to 1, what should we do, teacher?
If it's if it's equal to 1.
Yes, teacher.
If this is equal to 1,
If the equation equals to 1, what should we do, teacher?
okay, that is a pretty hard case since we don't have a constraint on the value of y and x, so this can be anywhere between 0 to 1. So is this square root. This can also be anywhere between 0 to 1, and the only constraint we have is that if you add these two things, you should get 1. So you wouldn't get a single value answer. Rather, I think you would get a range of answers, like an inequality, I think. So if we do that, we're gonna consider the extreme cases where this is 1 and this is 0, and the other extreme case where this is 0 and this is 1. So if we do this, so y is still 902 in this case. But if we're going to consider that the other extreme where this is 0 and this is 1, y would be equal to 901. So So the answer, so y would not have a single value, rather it would, this is what you would get. And it basically depends on what the value of x is. Yeah, so the actual value of y will depend on what the value of x is. So it's not going to be a straightforward answer like in questions in the first question. Does that answer your question?
Yes, teacher. Thank you, teacher.
Okay. So no more questions? Any questions? I think we can proceed to this. Okay, so x plus 2y is equal to 3 and 3x minus y is equal to 5. What is the value of y? So there are a number of ways a lot of ways to go around this problem. So what I will do is to multiply this entire thing with 3. So we will get 3x plus 2y is equal to 9. And then this equation, I will multiply it.
I think it's 6y.
Oh, yes. Yes. Okay, I'm sorry. That should be 6y. So I'm going to multiply. Or not really multiply. I'm going to subtract this equation with the second equation. So minus 3x minus. So if we subtract this equation with this equation, every sign here should be flipped. So we have minus 3x plus y is equal to 5 plus 5. So here, this is 0, and this is 7y, and here we get 14. So this is pretty straight. This should be straightforward. We get y is equal to 2. Are there any questions?
No,
No,
miss.
teacher.
No. Okay. We can proceed. So if x and y are positive integers and 3x plus 4y is equal to 33, find the minimum value of x plus y. So here, we can rewrite 3x plus 4y into 3x plus 3y plus y. So why is this? Why are we doing this? So that it becomes 3x plus y plus y. If we want to minimize this, we should try to make this as big as possible. So for that, and if we want to make this as big as possible, we should start with the smallest possible value of x. So if we assume that x is 1, we will get that that 4y is equal to 33 minus 3, that's 30. So this is obvious. This means that y is not a positive integer, so this is not a viable solution. So we can't go with this solution. If x is 2, This means that 4y is 27. This also means that y is not an integer, so we also cannot use this solution. If x is 3, we will get that 4y is equal to 24. This will give us an integer solution for y, which is 6. So with this, the biggest possible value of y is 6, and x plus y is obviously just 3 plus 6, which is 9. Are there any questions for this problem?
No.
No?
No, Disha.
Okay, there's no question. So we can now proceed. So evaluate this entire expression. Can you see the expression here, the big fraction? Or is it not clear enough? I think it's clear. I think it's clear.
Yes, it's clear.
Okay. So the numerator is the sum of the first 20 whole numbers, and the denominator is 0.1 squared plus 0.2 squared plus 0.3 squared plus so on and so forth until 1 squared. So what we will do here first is we're going to multiply the numerator and denominator by 100. So it's mostly to make the denominator easier to handle, but you can also choose to skip this part. So if we do this, we get 1 plus 2 plus 3 plus dot 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 plus 20 times 100. So we can distribute 100 in each addend, and we will get 1 squared plus 2 squared plus 3 squared plus dot 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 plus 10 squared. So to solve this question, you would need some equations. So the sum of the sum of the first n whole numbers, I mean, this is equal to n times n minus 1 divided by 2. And for the squares, it's a bit more complicated. You get n times n plus 1 times 2n plus 1 divided by 6. Let me check if this is correct. Yes, and okay, so I slight error here. This should be plus, not minus. Okay, so you will need this to solve this question. Okay, so we can then just plug in. So this is equal to 20 times 21, 20 plus 1 divided by 2 times 100 all over 10 plus 1 times 20 plus 1 over 6. Okay. So we can cancel this. And also this is just 2. And we can also cancel this. So we are left with 100 over 11 over 6. So we can bring 6 up. So this becomes 600 over 11. But I think the answer key prefers a whole number. So that's okay. So what we're going to do is this. And 594 divided by 11, if you're going to divide that, you should get 54. So this is the answer. I'm not entirely sure if you're allowed to put this as your answer. I think this should be allowed if you're going to do this in the actual exam. But they usually prefer that there's a whole number in mixed form like this, a whole number and then the proper fraction. Are there any questions for this, for number 10? Yes?
Yes, teacher. Teacher, when is become 1 square plus 2 square plus 3 square plus 10 square equal n multiply n plus 1 over 2 n plus 1 multiply 2 n plus 1 over 6, teacher. This formula.
This formula, are you?
Yes.
It's why, so you're asking about why that is the case? Like why this is the formula for the sum of squares? Is that your question? Like why this
Yes.
is? Yes? Okay. I am not entirely sure why this is the formula. Why this is the formula? I think it has something to. I think it has something to do with combinatorics, if I'm not mistaken, but I might be wrong. So yeah, this is one of the things that you do need to keep in mind if you want to know how to solve like the sum of first and squares. Okay, so it's not exact. Okay, so I look it up and it's not exactly something to do with combinatorics, but it's a pretty complicated. There's a pretty complicated reason why this is the case, and I don't think I can explain it concisely in this session. I'm sorry. Is that an so if you do want to know, you can look it up. You can look it up after. Okay, another question.
Teacher, I have another question.
Okay. Okay, any questions?
Yes.
Yes.
Teacher, if we type in the exam lab, it is, I don't think we might be type like 54 cis over 11, teacher. It might be confused, teacher.
Are you asking if the way, like the way you write
Yes,
the
teacher.
answer?
Yes, teacher.
You can try not to write your fractions. If you're going to answer in the exam, try not to write your fractions like this, especially if you're going to answer if your answer has a whole number, since as you can see this looks very confusing. So try like writing your fractions like this or like this. So just so that the checkers, the people can distinguish the whole number and the fraction. But if I don't know, but I think, as I said earlier, I think it's acceptable to write 600 over 11. So if you want to write it like horizontally, you can just write 600 over 11 instead. Does that answer your question?
Yes, teacher. Thank you, teacher.
Okay. So okay, so we're kind of running out of time. We still have quite a few questions to cover. So let's proceed. Okay. So find the value of this. So for the cubic case, like the sum of first n cubes, the formula for this is n squared plus no, not plus, n plus times n plus 1 squared over 4. So as to why this is the case, it's pretty complicated. I can't really explain it here, like at least not now. But this is the formula. So we know this. So we're going to rewrite this entire thing in a way that we can solve using this formula. So okay. So since it starts with 11, so we can say that it's 1 squared plus 2 squared plus 3 squared all over 220 cube. Oh, I mean cube. I did say squared. Okay, I'm sorry. So we can write this minus 1 cube plus 2 cube plus 3 cube plus blah, 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 plus 10 cube. So as you can see, this is the same as this one. I mean, that is the same thing. So we're going to apply this. We get 20 squared times 21 squared over 4 minus 10 squared minus 11 squared is 4. So this should give us so 20 squared is 400. If you divide it by 4, that is 100. And 10 squared is 100. If you divide it by 4, that is 25. 11 squared. 21 squared is 441 minus 11 squared is 121. So 100. Okay. So this is equal to 3025. Subtracting this, we should get 0. Okay. So this should be, so this is our answer. Are there any questions?
No,
No.
miss.
No,
Okay, no more questions. So we'll proceed to number 12. Okay, number 12, given A and B are positive real numbers and satisfy equations A squared plus B squared equals 79 and A plus B is equal to 9. Find the value of AB. So AB here means the product of A and B. Okay, let's start. So if you see A plus B, A squared plus B squared, or AB, if you see these three things, there's only one formula you need to keep in mind. And so can anyone tell me what this is equal to?
A square plus 3b plus b square.
So this is A squared plus 2AB
Plus B
squared.
square.
B square.
Okay. So A plus B, this is 9 squared. And we can write this as A squared plus, we can write this as 2AB plus A squared plus B squared is 79. So 81 is equal to 2AB plus 79. Subtracting 79 from both sides, we get 2 is equal to 2AB. This leaves us with AB is equal to 1. So this is our answer. AB is equal to 1. Are there any questions?
No, teacher.
No,
No.
miss, but wait, I wanna take a note.
Okay. Okay. So okay, is it okay now? Is it okay? Can we proceed?
Okay.
Okay. So a 3-digit number has exactly 3 positive factors. Find the maximum value of this 3-digit number. So for this, you need to understand the concept of prime numbers and composite numbers. So prime numbers have only 2 factors. That is 1 and the number itself. While composite has more than 2 factors. But let's say we have 6. So 6 is a composite number, and its factors are 1 and 6, 2 and 3.
2, 3.
So as you can see, it has 4 factors. So how can it be possible for a composite number to have exactly 3 factors? Yes.
Only square numbers have an odd amount of factors of our number.
Square a prime number.
So if you want to have a number that has exactly three factors, that number should be a square of a prime number. So let's take 3 for example. 3 is a prime number. You square this, you get 9. And 9 has factors of 1, 3, and 9. This means that 9 has exactly 3 factors. So what this problem is asking us is, it's asking us for the maximum 3-digit number that is a square of a prime number. And if you're familiar with your square, okay. We know that 30 squared is 900. This is pretty close to 1000 already. And 31 is a prime number. And if you square this, you get 961. Actually, and 32 squared is 1024. So this means that the largest 3-digit square is 961. And 31, since 31 is a prime number, we're sure that 961 has only 3 factors, namely 1, 31, and 961. So with this, the maximum value is 961. Are there any questions?
No, teacher.
No?
I wanna ask.
Okay.
So we have to find some squared number. So the value of squared number is maximum number of 3 digits. That's right?
Yes. But you don't, but not just a square. It's not just a square. It should be a square of a prime number because you want exactly 3 factors. So if the square happens to be like, if it happens to be a square of a composite number, it's going to have more than 3 factors. So it has to be a square of a prime number. Does that answer your question?
So if a prime number is squared,
Yes.
it's always have exactly 3 positive factor.
Yes.
Okay, thanks, Miss.
Any questions? Any more questions? I think, okay.
No,
No questions, so
no, teacher.
we can proceed.
Miss, I have a question, Miss.
Yes.
But couldn't it be, isn't the rule for the amount of factors of the square numbers only needing it to have an odd number of factors, not only 3? Because I can have 27 squared, but 27 itself have how many factors already?
So that's why what the number that you're squaring, 27 is a composite number, right? You need to make sure that the number you're squaring is not composite. It has to be a prime number, like 31.
Okay. Oh, okay, guys. Got it.
Yeah. Okay. So now I think we can proceed to the next question. Find the number of all positive factors of 830. So for this problem, we need to find the prime factorization of 830. That is to express this number as the product of its primes. So we have 415. 415 is 5 divided 83. So 83 times 5 times 2. Okay. So if you're it's implied that there is a 1 here, right? And what you're going to do is you're going to take these exponents, you're going to add 1, and you're going to multiply. So this is 2 times 2 times 2, which is 8. So I'm going to give another example of 100. So 100 is 2 squared times 5 squared. So I'm just doing this so that it's clear what it's the method for solving this is clear. I think let's do 50. Let's do 50. So this is 50 is 2 times 5 squared. So there's 1 here. So you're going to take the exponents. You're going to add 1 to each exponent. You're going to multiply all of them. So that's 2 times 3, 6. So 50 has 6 factors. And in this case, 830 has 8 factors. So any questions?
No, teacher.
So I wanna ask how to find all the factor. We just have to add the, what is that?
Exponent.
The exponent one.
So you take the prime factorization, you take all the exponents of the prime factors, you add each of them with 1, and you're going to multiply all of the numbers that you got. So here, so 1 plus 1, 1 plus 1, 1 plus 1, you're going to multiply all of that, and you get 8. Is that clear?
Yeah, I understand. Thanks, Miss.
Okay. So, any questions? No question. I think we can proceed. So, how many simplified fractions with denominator 101 are there? So, what can you notice with the number 101? Is it composite or is it prime?
I think 101 is prime number.
Yes, so
Also
101
prime.
is a prime number. So this means that whatever number it is, I want even go to 50, 51. These are all simplified already. These are all on their lowest terms. Because 101 is a prime, it doesn't have any common factor with any of the numerator except for 1. The only exception would be 101 over 101 itself. That would be 1. So as long as the number is less than 101, it should be a simplified fraction. So this means that there are 100 of them, and yeah, it's 100 this 3 over 101 dot 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 until 100 over 101. So all of this are simplified fractions. So therefore we have 100 of them. Any questions?
So is there only one fraction that can be simplified?
Well, okay, technical. Okay, so I'm, so I think, so well, in this problem, yes, but I just kind of realized the phrasing is kind of the phrasing is kind of dicey because it doesn't specify it should be a proper fraction. So it doesn't specify it should be a proper fraction, but it's supposed to be a proper fraction. So you cannot consider any fractions where the numerator is more than 101. So yes, yes, the only fraction that can be simplified is this in this case. Does that answer your question? Is that clear?
Clear. So the answer is 1.
No, the answer is 100 because okay, 101 can be simplified. Therefore, it is not on its simplest terms. The other 100 fractions, they cannot be simplified anymore. Therefore, it's already simplified. Is that clear?
Okay.
Any more questions?
No, this
Okay, none. Okay, so we can proceed. So find the integral part of this entire expression. Okay. Oh, okay, sorry. Wait, I accidentally skipped. So question 7. Hold on. Okay. Okay, so we can simplify it. We can rewrite this as this. 6 plus 1 and 7 plus 2018. I'm kidding. 1008. So we can already solve this. That is simply equal to 108 times 109. I mean 1009 over 2 over 2018. As you can notice, you can cancel this and this. This becomes 2. So we're left with 1008 over 2 over 2. So this is basically just 1008 over 4. This should be equal to 252. Are there any questions? So the answer is 252.
No.
No question, teacher.
Okay, so no question. And you can now proceed to this one. So this one is, it's essentially the same, but like the difference is the negative sign and also the last term is 10. So let's just put the negative here, and 1 is going to become 1 plus 2 plus 3 plus dot plus 9 plus 10, 2018. So this is equal to 10 times 11 over 2 all over 2080. Okay. And wait, I think there's a mistake in the question. Let me check. I think the question should have 1 here. 1 minus, yeah. So let's redo that. So 1 minus 2018, 1 plus 2 plus 3 plus dot 9 plus 10 is equal to 1 minus 10 times 11 2 all over 2018 equal to 1. So it's going to be cancelled by 55 over 2018. So it's equal to 2018 minus 55 over 2018. This should give us 3. Yes. So yes, okay. This any questions for this, for number 17?
Why is there one?
Okay. It's because the answer key had this answer, but like I realized the question was wrong. There should be 1 in here. If there's no 1, the answer would be different. It's going to be 55 over 2018. So that's my mistake. Any more questions?
I
Um,
have, teacher.
where's the
Okay.
decimal?
Decimal.
Decimal part.
Oh, okay. So this was the phrasing of the original question, but realistically, you cannot compute the actual decimal part in an exam, right? I mean, at least not without a calculator. So decimal part, this means the fractional part. So let's say you have a mixed number. This is the integer part. This is the fractional part. This is the fractional or the decimal part, supposedly. Does that answer your question?
Yeah.
Disha, hello.
Yes?
Disha, in the question and without one, if so, our answers might be minus 55 over 2008.
Yes, if the question had no 1, the answer would be negative 55 over 2018. Yes.
Yes, Disha. Thank you, Disha.
Any more questions? Okay, I think, okay, let's proceed to number 18. It is known that x is rational, x is greater than 0, and x is equal to this expression right here. So it's an infinite squared expression. Find the value of x. So if it tells us that x is equal to 3 over 3 over 3 over, and it goes on. So as you can see, this is still infinite. We can still express this as x. So instead of writing this clunky expression, we can just write it as like this. And to make this easier to solve, we're going to square the entire equation. So we get x squared equals 3x. I mean, I'm wrong. It's actually 9x. Okay. So yeah, you got pretty much this. So there's like 2 solutions to this. X is equal to 0 or x is equal to 9. However, so x 0 and 9 are both rational. However, it does tell us that x is greater than 0. So x is equal to 9. Any questions?
No. No,
Okay, no questions. So we can proceed to number 19. If it is known the two sides adjacent to the right angle of a right-angled triangle are in the ratio of 3:4. If the length of the hypotenuse is 16, find the area of the triangle. So I want to review on Pythagorean triples first. If the sides of a right triangle, if the sides of the right triangle are 3 and 4, what will be your hypotenuse? So what is the length of
5.
So it's 5. So yes, it's 5. However, in this problem, it tells us that the length of the hypotenuse is 16. So
Ratio 3.2.
yes, question?
No.
No? Okay. So this is the ratio of all the sides of the triangle. So 16, that is, I'm just going to write this to make it easier to see. So this is 16, so this is 16. This side would then be 3 over 5. And this side would then be 16 times 4 over 5. So as you can see, the ratio is still intact. It's still 3:4:5, but we match it such that the hypotenuse would be 16. So that means this is the length of this is the length of the sides. So okay, so what would then be our area? It's base
One
times
over two pH.
it's base times height. So the area is base times height over 2. So basically we're just going to multiply this and this and divide the entire thing by 2. This will give us 16. So 8 times 3, 24 times 64 over 25. This should give us, oh, um,
61.44.
61.44. Yes, it is 61.44, but yes, but okay. Any questions?
What is the answer? Is that 61.44?
Yeah, but you can also I think you can also express this in fraction. 61:11 over. This is how you would express it if it were in fraction form.
It must be a simplified fraction.
Yes, it has to be a simplified fraction. No questions?
Why it's 3/5 and 4/5?
3/5 and 4/5. Are you asking about these?
Yes.
So we know that the ratio of the sides is this, right? So that's why I wrote 3/5 and 4/5, since you're going to be like multiplying the entire thing by 16. So we can get the actual length of the sides in a way that maintains this ratio. Since it's
Okay.
the hypotenuse is 16. Yes. Okay. Any more questions?
Okay, thank you.
No questions? I think we can proceed. For 4 points on a coordinate plane, point A is at 2, 0, B is at 2, 4, C is at -6, 4, and D with an unknown location. Find the area of the rectangle formed by using these 4 points as vertices. Oh, sorry. So we're going to plot this. -6. Can you see the, I don't think it's visible. Let me okay. So this is y, this is x. And as we can see, the format is xy. So 2, 0, that would be located here. 0. So this is A. B is a 2, 4. So the x is 2, the y is 4. C is negative 6, 4. So the x is here, the y is here. You see? And since it's a rectangle, we're pretty sure, even though the location is unknown, it's not given. We're sure that D is here, since the shape should be a rectangle. So we want to find the area of this. So this is simply length times width. So the length here, this is from 0 to 4, so it's 4. The width is from negative 6 to 2, so that would be 8. So the area is simply 8 times 4, which is 32. So our answer, the area is equal to 32. Any questions?
I wanna ask why the D point is on coordinate -6, 0.
Because that's the only point where that would make this figure a rectangle. If you put it anywhere else, this would not be a rectangle. You can see here. So the
Okay,
point
okay.
is also
I
rectangle.
understand. Thanks, Miss.
Yes. Any questions?
No
Any more
questions,
questions?
teacher.
Okay. No question. So we can proceed with 21. In the figure below, AB is perpendicular. So the symbol means perpendicular to CD. AB is perpendicular to AD, and AD over AB is equal to square root of B. So we're tasked to find the ratio of CD over CB. So we're sure that these are right. This is a right angle because of the given. And this is also a right angle. So AD, AB. Oh. So AD over AB is square root of 3. Okay, so this makes the triangle a right triangle. And here, within here, it is also a right triangle. So let's say we put an angle here of, let's say this angle is x, and the angle here is y. So this angle would then be equal to y, and this angle would then be equal to x. This basically implies that there is some sort of ratio and proportions in the sides, because they essentially have the same angles. So we're going to erase this. So we know that the length of AD is the length of AB multiplied by square root of 3. This is AB. So So, okay. So this means, so if you apply the Pythagorean theorem, this entire line would have a length of 2AB. Okay, never mind. Okay, so if this, okay, so if this is, okay, it is, okay, we'll do this. So this is equal to 2AB. And what this tells us about CB, since I established earlier that there should be some sort of proportionality, I mean ratio or and proportion between the triangles. This is 3AB, this is AB, ABD. This is, oh, sorry. A, B, A, B, so AB, so AB. So for what we can see here, this means that CB, the length of CB is half the length of AB, and the length of AC should have the length of AB times square root of 3/2. And lastly, DCA. So AB has AB. So this implies that CA has this length and DC has wait. Okay, wait. If I like to see. So we have AB. We have AB. This square root of 3AB. And okay. So are you guys still following or are there questions or clarifications?
Teacher, in the picture AC triangle ACB and triangle DCB.
Yes.
Why it is divided by 2, teacher?
Yes.
Why?
Why another triangle like ACB and DCA is divided to?
Okay. So okay. So for this triangle, so this triangle is the big triangle, right? And this triangle, we know from the big triangle that this is AB. But because they have similar angles, as you can see, this is y, this is x. So the ratio of the sides should be the same. But here, the hypotenuse is AB. So if we want to find the sides of the length of these sides, we're going to take this and divide it by 2. Since 2AB is since AB is half of 2AB. So we're going to do the same to the other side. So we're going to have this, and we're going to take the half of this. So that's for this triangle. For this triangle, you can see that we multiplied this with square root of 3. So if you want to find the length of these sides, you will have to multiply this by square root of 3. Does that answer the question? Is this clear? Is this clear?
Okay.
Yes.
Okay. So now we can evaluate this ratio. So CD, this is 3/2 AB. CB is this. So that's AB 1/2 AB. So as you can see, the ratio is 3. So no more questions. Are there any questions?
I want to ask,
Yes.
what is there is a symbol between AB and CD, and then there's a symbol again between AB and AD. What does this mean?
Okay, so if AB and CD are line segments, so this means perpendicular. So as you can see, AB. Oh, but they're disconnected. Oh, I think this should be B. It should be B. Or no, it should be A. So it means perpendicular. So the symbol, this means that the two lines are perpendicular. So in this case, for AB and AD, so it means that AB and AD are perpendicular. Does that answer your question?
But that says AB is perpendicular to AD, and then AB is perpendicular to AD.
Oh, this. I see. I think this. Okay. This should be AC. There. So that's the correct. This is the correct question, and so that's my mistake. Any questions?
Disha, in the figure, CED might be 2AB, right?
Yes. Can you repeat that?
Disha, in the figure, CD, CB or CD, which one is 2AB, Disha?
Which one is AB and A?
Disha, this one. 2AB is for BD.
Oh,
Or not, Disha.
wait. So you're asking which side has 2
2AB. Yes.
Has 2AB. This long side. This is 2AB. This is a
Yes,
line.
teacher.
Any questions? Any questions? Okay, I think we can proceed to 22. So what is the sum of the exterior angles of a decagon? Just to clarify, let's say I have a triangle here. So let's say I have a triangle. So an interior angle. So this is an example of an interior angle. Well, if we extend this line, so we extend this line, we get this angle. This is called the exterior angle. So it's asking that for a 10-sided polygon, what is the sum of all of the exterior angles? Okay. So can anyone tell me what the sum of the interior angles of, so let's say I have a polygon with n sides. So what would then be the sum of the interior angles?
Miss,
Yes,
is there any formula to find the sum of interior angle for n side?
yes, there should be a formula for this. So, in case
Minus 2 multiply 180 degree.
yes, so you take n, you subtract 2, and then you multiply this by 180. So from what I showed you about exterior angles, so I think, wait, so a straight line, you guys know that a straight line has 180 degrees, right? So this should be 180 degrees. So let's say this is A. The exterior angle would then have an angle of 180 degrees minus A. So we would then have, so if you multiply it by 10, okay, wait, okay. So let's consider the end sides first. So this is the sum of the interior angles. And you have, and then you extend a line, and then you get the exterior angle. So each exterior angle should have 180 minus 180 and minus 2 over n. So this is the measure of each interior angle. Let's say if they were let's say they had the same side, the same angle, I mean. So this is the exterior angle. Then you're going to multiply this by n. What you can see is 180n minus 180. 180n minus 360. So basically what what we're doing here is that we can see that the sum of exterior angles of, it doesn't matter if it has 10 sides or how many sides, the answer is going to be 360. So I'm going to explain it. So, okay. So the answer is 360. So, okay, I think I explained that badly once, so I'm going to explain it again. So let's say I have a triangle. So this is the interior angle. This is the exterior angle. So we know that the sum of interior angles for a triangle is 180 degrees. And if we're going to divide this by 3, we would know that each angle would be, each interior angle is 60 degrees. So this means that the exterior angle is 120. And if we multiply that by 3, we would get 360. And this 360 result, this will be true for any number of sides. So this is also true for a decagon, which has 10 sides. So yes, the answer is 360. Are there any questions?
I have a question.
Yes.
Is the exterior angles of n side polygon is always 360 or more?
The sum, if we're going to get the sum of the exterior angles, it's always going to be 360.
Oh, without any formula, it's always 360.
Yes, it's always 360 degrees.
Oh, okay. Thanks, Miss.
Any more questions?
So if the side like 8, 9, the exterior angle still 316.
So yes, even if the polygon has 8 or 9 sides, it's still going to be the sum of exterior angles, it's still going to be 360.
Okay, miss, thank you.
More question? Any more question?
No question, teacher.
Okay, so no questions. So, okay, so, is it okay if this is our, so is this our second last question? So this is going to be our second last question. So for rectangles whose side lengths are integers and its area is 22,015 centimeters squared, how many different values of perimeter can it take? So since the side lengths are integers, we can just take the factors of 2015. So that's 1 times 2015 and 403 and so okay, so so 403 is apparently equal to 13 times 31. So we have more factors here. There's 13 of 5 times 31 is 165. 155, I mean, and 31 and 65. Okay. So these are all the possible side lengths of the rectangles with an area of 2015 square centimeter. So since we have 4 pairs here, this will generate 4 different values of perimeter. So therefore, the answer is 4. Are there any questions?
I wanna ask how we can find different value of perimeter can it take? I mean, its area is 2015, and then where can we find 4 different value?
So you're going to consider different side lengths that
Yeah.
will have an area of 2015. So that's what we're doing here. So it could be 1 and 2015 could be 5 and 403, could be this, and it could be this. So this will give us 4 different perimeters. So yeah, 4.
I mean, how can I imagine that
Um,
that
uh,
there is 4 different value, like I will divide it by 5, by 13, maybe. How can
value,
I imagine that?
you're going to, so you're going to consider, you're going to get the factors. Or if you want to, get, if you want a more, like, if you want a method that can work for any area, you're going to get the number of factors. So I think I already discussed how to do that, how to get the number of factors of a number using the prime factorization. And then if you get that, you're going to divide it by 2. So does that answer your question?
So firstly, I can do a prime factor of
Oh,
2015, and then how?
okay. So yeah, 2015 is pretty tricky, especially if you can see that this is product of 13 and 31. But if the value was different, I think it would be more straightforward. Any more questions?
No,
No questions? Okay, so we're going to proceed to our last question because we're going way over time. Find the value of h in the attached figure. So this is kind of the same as the ABCD triangle, but here we have the actual the actual side. So 7, 24, and 25. This is actually Pythagorean triple. So we're confident that this is a right triangle. So I'm just going to, so this is H, by the way. So I'm just going to show you a shortcut method if you want to find the value of H. So first, I'm going to multiply this. And then you're going to divide it by this. So 7 times 24, that should be 168 over 25. If you want to mix fraction, that's just 3 times 8, 3 and 18, 25. So that's the answer. Any questions?
Just multiply 7 and 24 and divided it by 25?
Yeah. Yes. Wait, hold. Yes. So you're going to multiply 724, then you're going to divide it by 5. Any more questions? Any more questions?
No questions, teacher.
Okay,
No.
so this is going to be our last question. I'm sorry we didn't get to discuss any combinatorics.
Teacher,
Uh,
I would like to know question 30, how to solve. I'm a bit confused about question 30, teacher.
30. You want to see
Yes,
question
teacher.
30?
Yes, teacher.
Okay. Okay, section 30. Clear. Close. Okay. There are 47 students in grade 8. So 27 and 25 students like playing basketball and volleyball respectively. However, we don't know the number of students who like both ball games. Find the maximum number of students who don't like ball games. So what we're going to do here is we're going to draw a Venn diagram. So you can choose not to do this, but if you want the question, the problem to be more clear with a clear visual, so yes. So this is basket. So this circle represents the people who like the students who like basketball, and the students who like volleyball. The intersection here, it's for the students who like both. And here is going to be the students who doesn't like any ball games, the area here outside. So we know that there are 47 students in total. We know that there are 27 students who like basketball, 25 students who like volleyball. That's here. But we don't know the value here in the intersection and the value here. So if we want to maximize the number of students here, we're going to have to minimize the students here. So 27. So we're going to add these first. We get 52. And this is already more than 47 students. So we know that we're sure that there are students who like both basketball and volleyball. So minus 47, that will be 5. So if there are a total of 27 students that like basketball, this would be 22. There would be 20, so 22 means the number of students who only like basketball. And for here, the number of students who only like volleyball, that will be 20. If we add all of this, you would get 47. So, however, that would mean we would have no students that don't like both ball games. So, okay. So let's assume there is one student here. That would mean that would mean there would only be students here. Oh, sorry. So this would be 24, and this would be 22. Okay, add on this. Wait, hold on. The answer for the last. Okay. Okay, wait. Let's start over. I'm sorry. So this is the number of people like basketball, the number of people like volleyball. And we know that there are 27 and a total of 25. So if we want to maximize this, the number of people who don't like ball games, we need to minimize this. So I think one way we can do that is we're going to have this. So since the number of people who like volleyball are less than the number of people who like basketball, we're going to have the number of people who like volleyball here and the number of people who like basketball here. So we know there's 25 of them, and the total number of people who like basketball is 27, so this would be 2. So we now know that the total number of people who like a ball game, that would be 27. So since there are a total of 47 students, we're sure that the number of people who don't like any ball games would be 20. So yes, the answer is 20. I'm sorry for that, guys. Are there any questions for this question for number 30?
I wanna ask.
Yes.
Which diagram? Oh, okay. So we use which diagrams?
Yeah, you can use this if you want a clear representation of the problem. Is that what you're asking about? The Venn diagram?
I wanna ask about below the diagram. So if the student who like volleyball is 25.
The total
So
number of students who like volleyball, there's 25 of them. Yes.
So that's 25 students like both basketball and volleyball. So only 2 students who like basketball maybe?
Yeah, so yes, so in this diagram, you can make it such that all the students who like volleyball also like basketball, since it's not stated here that they only like volleyball or they only like basketball. And yes, there are only 2 students who only like basketball. So that is the case in which we can maximize the number of students that don't like ball games. Does that answer your question?
Okay, miss. I understand. Thanks.
Okay. Any more questions?
For number 24, the fact.
Yes, you're asking about question 24.
And the fraction was 168 divided by 25, right?
Yes. Yes.
So why was the answer 3, the whole number is 3 and then 18 over 25?
Like the whole Okay, I'm just going to answer that here. 106. Oh, okay. Okay, I see. So that's okay. That's my mistake. That is wrong. Actually, it should be 6. 6 and 9 over 9. 18 over 25. It should be 6, not 3. So that's my mistake. Oh, sorry. It should be
Okay.
6. Okay. Thank you for catching that. Any more questions?
Teacher, I have.
Yes.
Teacher, for the answers for question 29 is 40 over 663. Is that right?
40 over 663. So you're asking.
Yes. For question 29, teacher.
So you're asking. Well, wait, hold on. So you're asking about number. You're asking about this. Yes, it is 40 over 663. But I think we're going way over time, so I I can't really explain it. But is it okay if uh I'll if I send a written solution and it will be then emailed to you? Is that okay for all of you?
Yes, teacher.
Yes, that's okay.
Okay. So uh so that's it for this session. Thank you very much for listening and for engaging with today. So okay, so you may now leave. So I'll stop. Oh, I'll stop recording too.
Miss,
Yes.
uh, where was you send solution for question number 25 until 29?
Uh, it will be. I will ask Anna. I will ask it that. I will ask to be sent it to email. Your email.
My email?
Yes. So if you want to see the solutions, please do check your emails. So
Yes, teacher.
you
Teacher, chat is disabled, teacher.
yes.
Chat is disabled. We couldn't write, teacher. We couldn't write anything in the chat, teacher.
Oh, in the chat, you still can
Yes.
type anything in the chat.
Yes, I still can, teacher.
Okay, I'm not sure why that's the case, but okay. So I'll stop recording now.